Hello, scholars, and welcome to our lesson on exterior angles of triangles. This is in angles and triangle theorems, and the goal is that you will be able to use the rules of exterior angles of triangles to find unknown information. The reason we're doing all of this is, as mentioned before, triangles are one of the strongest shapes we have in our world, and that is literal. There's a reason that triangles are used for so many of our bridges in architecture. They genuinely are one of our strongest shapes. And they're also one of our strongest mathematically. Being able to understand and use the methods to solve problems involving one of our most used shapes helps us better understand and work in our world. Let's begin. First, with our warm-up pop-up. So, this is a multi-step process. Step 1, find the value of C in the triangle shown. We have a triangle here. We have A, we have B, and we have C, the mystery. So that's your first job. Find out what C is. Now that you've done so, if we extend the line, what is the value of X? Doing a check-in. First, to find out what C is, using what you've recently learned, you should have known that this mystery angle plus 40 plus 35 should have given you 180. So if you said 40 plus 35 plus their mystery angle should give me 180. If you combine 40 and 35 and got 75, plus our mystery gives you 180. And if you took away 75 to both sides, if you got that our missing piece, which is angle C, if you got in the end that it is, what would that be, 105? Yep, if you got 105 for angle C, you would have been absolutely correct. Now, the next part uses something you learned in the past, which is, you may have noticed, if you know that angle C is 105, altogether, it's making a straight line with X. So if you then knew, hey, if we combine these, we should get 180, right? So if you said 105 plus X gives you 180, you'd have been right. If you took away 105 to both sides, and you got that X is, well, 180 minus 105 is 75, you would have been absolutely correct. Now looking at what step 3 is. Last step. Add the two values of corner A and corner B together. What do you notice? Which, if you did it my way, you already did add the corners of A and B together. You get 75. Is there anything you notice about what we done here and what we ended up doing over here? Now, mind you, there's a lot of things you could notice, but you may have noticed that when we combine these, we got 75. And the answer we got for X is also 75, which might be a coincidence, but it's an interesting thing to notice. With that, I'm going to clear this up. Let's go. Oh, we had some additional things to help guide us, but we already did it. So we have the exterior and remote interior triangle angles. When looking at the exterior angles of triangles, they always have remote interior angles. This is some new vocab. Inside angles that the exterior is not touching. So for instance, looking at this triangle, this is the exterior angle outside the triangle, and not the angle touching this one, but the other two inside are remote interior angles. Remote meaning they're not touching this corner, and interior meaning they're inside. Here's another example. This one, now it's on the top, so it's the actually two bottom ones of the remote interior. Here's another one. So we have A over here, meaning if this is our exterior angle, the remote interiors are on the opposite side. Just some important vocab. Now we're going to talk about what happened in the warm-up. It isn't actually a coincidence. It just so happens that the sum of the measures of the remote interior angles is equal to their exterior angle. So if we were trying to find angle X all along, instead of doing all of that extra math, we could have just added our remote interior angles together. So we have a triangle here. It has an exterior angle, A. And then it has remote interior angle, B, which fits into A. And then if we take the other remote interior angle, C, if we move it over there, guess what? They perfectly fill and complete angle A, the exterior angle. And that's the equation, that the measurement of angle A, the exterior angle, equals the two remote interior angles added together. You can also write it the other way, that angle B plus angle C equals angle A, but it's the same thing. Now let's use it to solve problems. We have a more simplistic problem and a more complex problem. Step 1 is identify your remote interior angles and exterior angle. That is important. So with that, let me get my pen out. We'll do remote interiors in blue. So we have this one. I know it's kind of oddly floating there, but that is our remote interior angle. So this one and this one. And then this is our exterior angle, and it is our missing piece. So I have done that. I can also do that for my other ones. Do you remember, Skip reminded us in a previous lesson that this square means 90. So we have 90, we have 35, and we have 3z plus 2. That's our second one. Our step 2 is write the equation for exterior angles and solve the equation. Which, again, I'll do it for this first one. That is that our two remote interior angles add together to equal the exterior angle. So that's 31 plus 118 should equal our mystery angle, which in this case I say is angle F. Well, let's solve. If I add these together, 31 plus 118, I get 149. And sometime, ooh, that's not 149. 149. There we go. Now, sometimes you'd have to do some subtraction or division, but actually, angle F is already on its own, so this is it. Angle F is 149. I could put it the other way, so angle F is 149. Oop. That's it. The inner angles, the remote interior angles, add together to equal the exterior angle. Now let's do that with a more complex problem. Over here, we have 90 and 35 are interior. So 90 plus 35 should equal this whole thing here, which is 3z plus 2. So 3z plus 2. And I don't know if you've ever seen me do this, but if I ever write z's, I always put a cross through them. This is a thing that mathematicians use because z's and 2's look too close together. So if you see what looks like a 2 but has a cross through it, you know it is a z, not a 2. On that note, let's actually try to solve for z in this case. Let's see. We have 90 plus 35. We can combine those terms. It's 125 equals 3z plus 2. Now, normally, traditionally, we would want the variable to be on the left side. We could move it all over, but you can keep it on the right side, which for quickness, I will do so. Meaning, I'm going to subtract 2 to both sides to get z on its own. 125 minus 2 is 123. We have 3z on this side. The last step is let's divide both sides by 3. And 123 divided by 3 is 41. So I'll put it over here. That means that z is 41. Again, more complex, but it starts out the same way, that the two remote interior angles add together to equal the exterior angle. Make sure to pause if you need to get your notes in, but I'm going to clear this up and head to the U-Try, which means it's time to see what you can do with similar problems. Pause the video and try these on your own. All right, doing a check-in here. Pause if you're not ready. For the first one, you this time have x and 19 are your inner angles. So let's put x plus 19 equals 76. and I need to solve for x. If you said, well, I need to solve for x, so I actually need to subtract 19 to both sides, you would have been right. And 76 minus 19 is 57. So if you got that x is 57, you absolutely solved it correctly. The more complicated one, your inner angles are 37 and 6r plus 1. Your exterior is 74. So if you set this up, you would have said 37 plus 6r plus 1 equals 74. And now you have an equation to solve for. If you notice you had like terms, you want to combine those first, I would agree with you. 37 plus 1 is 38. So now you have 38 plus 6r equals 74. If you then said, well, I need to take away 38 to both sides, you would have been absolutely correct. We'd have 6r on the left. On the right, you should have gotten 74 minus 38 is 36. Lastly, if you decided to divide both sides by 6, you would have been absolutely correct, and you should have gotten that r is 36 divided by 6 is 6. So if you got that r is 6, then you solved that more complex situation correctly. Pause if you need to make any corrections, but if you got everything right, we're going to go to the closing, which is that the sum of the remote interior angles of any triangle always equals their exterior angle. So that's another tool in solving triangles we can use. With that, that is the end of our lesson on exterior triangle angles, but I will be seeing you in some future lesson videos.